In the last video, we created a simple panel module and populated it onto a grid. This was modeled on the top view, which is the XY plane. If you want to put the panel on a vertical facade, you can set the grid to the XZ plane. You can immediately notice that the circular holes on the panels are gone because the circles and the grid cells are not on the same plane. The simplest fix is to change the normal of the circles to face Y direction. This simple test shows us that we have to make sure that the panel module and the grid always face the same direction. What happens when the grid is not on a planar surface? How can we make sure that the normal of the panel module is always consistent with the normal of the grid? Let's start from an empty canvas and model this example. Create a circle and set the center point to 0, 0, 0 and the radius to 30. Use a move battery to copy the circle along the Z direction. Use a series battery to make multiple copies of the circle. Set the step and the count to arbitrary values. Use the coal index battery to separate lower circles and the upper circles. Set the index to 0 and -1 respectively. Now, the upper battery contains all circles but the one at the bottom. The lower battery contains all circles but the one on the top. Divide both groups of circles. Let's set the number of the divisions to 30. Use the shift list battery to shift the indices of the points by 1. Now we have the grid points set up. To verify it, let's use the list item battery for the points. Since it is a tree structure, let's flatten the input. Make copies of the other 3 groups of the points. Now, if you click the list item batteries in sequence, you can confirm the 4 points for the first rectangular grid. Keep your eyes on the Rhino viewport. This is the bottom left point, top left, top right, and the bottom right. From our previous example of the flat panel, copy the panel module portion of the definition. Paste it into the cylindrical example. Connect the radius slider to the circle. Now, if you connect the list item batteries to the points for the module, you can get the first panel on the cylindrical model. But again, the hole disappeared because the normal direction of the panel and the direction of the grid cell are inconsistent. You might think that we can set the normal of the circle to face the X direction, but it still does not create the hole because the grid cell is not exactly on the YZ plane, which should be aligned with this line, but it is actually slightly off the plane. You can imagine how difficult it is to individually tune the normal when the grid cells are all facing different directions. Let's first populate all panels to the entire grid cells. The geometry in the Rhino viewport is not what we expected. The reason is that each of the branch of the tree structure contains 30 points, not 1. So we need to graph the 4 batteries to change the data structure. However, you don't see the rectangular cells, but only vertical lines. If you hover your mouse over the V input, each tree branch only contains 2 inputs, not 4. This is because the tree structures of the input data are different. If you look at the index of the last line, this one is 6:29, while this one is 6:0:29. This was caused by the shift list battery, which adds an additional zeros at the end when compared to the original divide battery. To resolve this, we can simplify all 4 batteries to make the tree structure consistent. Now, we can see the rectangular cells. The only issue left is the missing holes on the panels due to the inconsistent normal directions. Let's use this one panel as an example to explain the solution. We can create a vector between these 2 points along this direction, and another vector between these 2 points along this direction. Then use the cross product of the 2 vectors to derive the normal direction, which is perpendicular to the 2 vectors. Please refer to the vector videos if you don't fully understand the logic. Let's use the vector 2-point battery to create 2 vectors. From here to here, and from here to here. Then get the cross product between the 2 vectors. Use the output vectors as the normal of the circles. Now you can see that no matter which direction the grid cell faces, the circle will always face the same direction. Thus, it creates holes on the panels as intended.